Today we're going to talk about the negative and zero exponents, which is another part of the laws of exponents. We've been working with multiplying and dividing them yesterday and the power rule. And so today we're going to look at negative and zero exponents and how they work into things. So first of all, to explain these, we're going to take a look at 2 raised to a power first of all, and how that applies to negative and zero exponents. So first of all, let's look at what they are. So we've got 2 to the first power. Well, we know that's 2. And 2 squared is 4, because just multiply 2 times 2. 2 cubed is 8. And 2 to the 4th is 16. And 2 to the 5th is 32. Okay. So for each one of these, each time to get from 2 to the 4th power to 2 to the 8th power, or 2 to the 3rd power to get to 16 to 32. Each time we just multiplied by 2. Okay. So, but what happens if we go the other direction then? So let's say we've got, let's put in here 2 to the power of 0. Well, how do I get 2 to the power of 0 then? Well, since we multiplied each time to get from 2 to 4 to 8 to 16 to 32, if we work our way backwards, that means instead of multiplying, we are dividing each time by 2 to work our way backwards. So to get from 2 to 2 to the power of 0, then, we're going to work our way backwards. So that means we're going to divide by 2. Right? And so 2 divided by 2 then is 1. So when I divide by 2 here, to back up to there, then this is equal to 1 because 2 divided by 2 is 1. Well, okay, so that's good. So how about if we work with negative exponents then? Let's go even further. 2 to the negative first. Well, if I divide by 2 again, then I'm going to get 1/2. Okay? Divide by 2 again. 2 to the negative second. Well, that would be, if I divide by 2 again, that gives me 1/4, which is the same as 1 divided by 2 squared. Because over down here, we have 2 to the second power is 4, so 1 over 2 squared is going to be 1 over 4. And if we go even farther with this, make it 2 to the negative third then. 2 to the negative third, well, that's going to be 1 over 8, which is simply 1 over 2 to the third power. So what happens here, right? So what happens is that when we are working with negative exponents, we are actually, what we're going to be doing is we're going to be taking the reciprocal and change the exponent to positive. All right. Or another way to look at it is that right now our exponent is in the numerator. We're going to move it to the denominator and make it positive also. So whenever we have a negative exponent, then we're going to change it to a positive exponent. We just move it to the other part of the fraction, or change it from positive to negative. So if we had, say, 3 to the 8th power, or 3 to the negative 8th power, okay, then that's going to be 1 over 3 to the power of 8. Or if we have x to the negative 5th power, that would be 1 over x to the 5th. Okay, so anytime we've got a negative exponent, we're going to move it to the denominator, okay, or take the reciprocal and change the exponent to positive. So anything that was here, 3 to the negative 8, that's like 3 over 1, so it becomes 1 over 3 to the 8th. Now the other power is looking at the 0 power. Okay? So anytime we have the power of 0 or a 0 power, that always equals 1. So here we had 2 to the power of 0 equals 1. If we have anything else to the power of 0, like say 4 to the power of 0, that would be 1. Or negative 123 to the power of 0. That's equal to 1. Right? So the two basic things are right here, right now. Negative exponents. We take the reciprocal and change the exponent to positive. Or we can think of it as putting it in the other part of the fraction, making it positive. And as we look at this more, then it'll make more sense. All right, so here's a couple of examples here. So 2 to the negative third, all right, well, we looked at that. That is equal to 1 over 2 to the third power. So we change it to 1 over that because it was 2 over 1. So now we make it 1 over 2 to the third power, which is 1 over 8. X to the negative fourth. Right? Same thing. This becomes 1 over x to the fourth. All right, so we're just moving it to the denominator, changing the exponent to positive. All right, 3 to the negative second. 1 over 3 squared, which is 1 over 9. All right, now this one's a little bit different. Here we have 2y to the negative fourth. So to do this 2y to the negative fourth, we have to figure out, okay, what's raised to the power, first of all. Okay? In this case, our base for the power is y. 2 is not a base in this case, because in this case, y is the only thing raised to the fourth power. So the power is negative 4. So right now, the power for the 2 is 1. The power for the y is negative 4. So that's the only thing I'm going to change. So this becomes 2 times 1 over y to the fourth power. Or we'll write it as 2 over y to the fourth. So just be careful that with your exponents, in this case, it only applies to the y. It does not apply to the 2. So with negative exponents, if it's in the numerator, we're going to put it in the denominator, make it positive. If it's in the denominator, which we'll look at them in a minute, we'll move them to the numerator and make them positive. So one thing to remember as these get a little bit more complicated is to remember our agendas and how those apply also. So with the next one, 2x squared, y to the negative third, z to the second. So all we're looking at is which ones have negative exponents. And if they have negative exponents, we're going to move them to the denominator. And we're also looking for simplifying. So in this one, it's really nice. They just give us 2, an x squared, y to the negative third, z squared. So the only thing I have to change here is I have y to the negative third. So we're going to have 2x squared, z squared is still in the numerator. And the y goes to the denominator, and we change the sign to a positive 3 instead of a negative 3. Okay? Look at this next one. 1/4, a to the negative second, b to the fifth, c to the negative third. So anything that we see that has a negative exponent, we're going to move that whole piece to the denominator and change it to a positive exponent. All right? So in this case, we have 1/4, so we're going to go ahead and put our fraction bar here. The only thing with a positive exponent is the 1 and the b to the fifth. All right? So we have b to the fifth. That stays here. Does not change because the exponent was positive. Now, we have 1/4, so that means that the 4 is in the denominator already. And then we're going to take the a and the c, put them in the denominator, and we're going to change those exponents to positive. All right, and the reason that we had GEMDAs up there is we have to remember our rules for GEMDAs. That on these last two we were looking at, there was no simplification, just a matter of writing them with positive exponents. In this one here, we first of all have to use a multiplication rule. Right? And with that multiplication rule, we have to remember that with exponents, when we have an exponent, then we are going to multiply the exponents together. So right here we have 3 to the first power, x to the negative third, y to the 0. So we are going to multiply the exponents by 2. So 1 times 2 is 2. X, negative 3 times 2 is negative 6. Y, 0 times 2 is 0. So when I finish this then, 3 squared is 9. X to the 6, that goes to the denominator, becomes positive exponent. And y to the 0 is just 1, because anything to the power of 0 is 1. So we don't even need a y then, because that whole part is equal to 1. So my final answer here is just going to be 9 over x to the 6th. Okay, the last one here. We're using our, if we have multiplying with the same base, we add the exponents. So that's the first thing we're going to do is we're going to go ahead and rewrite this first of all. So I'm going to rewrite it so I put the constants together, the m's together, and the n's together. So we get 2 times 3. M to the 4th, m to the negative 3rd. N and n to the negative 5th. All right. So first, just putting those together, the variables together, will help me in my simplification. So 2 times 3, that's 6. M to the 4th times m to the negative 3rd, we add those exponents. 4 plus a negative 3 is 1. Then n times n to the negative 5th, so we have 1 plus negative 5 is negative 4. So here we have a negative exponent again. So this is going to be 6m, they're going to be in the numerator. Since n was the negative exponent, I move it to the denominator and change that exponent to positive. Okay? All right, let's look at a couple more. All right, so here we have 4x squared y to the negative 3rd over 2x to the 5th z squared z to the 4th. Y squared z to the 4th. All right, so to simplify this, there's a couple different things we can do. All right. First of all, let's look at that we're going to end up with a fraction bar regardless of what we're doing. So let's put a fraction bar in here. All right. Now, any negative exponents you have, my suggestion to you is this. If you have negative exponents, move them to the other part of the fraction and make the exponent positive. All right? So right now we only have one negative exponent, okay, the negative 3. So I'm going to, first of all, I'm going to rewrite this so that I have just positive exponents. So in my numerator, I have 4x squared only. In the denominator, I now have 2x to the 5th, y squared, z to the 4th, and I'm going to move this y to the negative 3rd, because as a negative exponent, I'm going to move it to the denominator and it becomes a positive 3. Right? The other part of the fraction. Right? Now I'm going to simplify anything on the numerator or the denominator can be simplified. So we have 4x squared in the numerator. Nothing I can simplify there. But in the denominator, I have the two y's. So I'm going to put them together. So we have 2x to the 5th, y to the 5th, and z to the 4th power. So we put those y's together, all right, to help us out. All right, so the next thing then is we are going to simplify this whole fraction. Well, I'm having issues here. All right, let's get it back where it was. All right, let's pull this down here, move this. All right, make it a little bit easier for us. All right, so when we simplify this, we are going to use the quotient rule for anything that is in the numerator and the denominator. So first of all, we have a 4 over 2. So 4 divided by 2, that is 2. So that's in the numerator. Now it's going to be the only thing we have left in the numerator, because now when we look at these powers, all of the bigger powers are in the denominator. So we have x to the 5th in the denominator, x to the 2nd in the numerator. If we use the quotient property, it says we subtract the exponents. Well, we are going to subtract them in this case, but we're going to subtract 5 minus 2 instead of 2 minus 5. So we don't get the negative exponent. So 5 minus 2 gives us x cubed in the denominator. Because if we wrote it out, we would write it out, we'd have 2x's in the numerator and 5 in the denominator, so that we would subtract 2 of them from both, which would leave us with 3 in the denominator. And then we got y to the 5th and z to the 4th. And those just stay right in the denominator then because they are positive. So here is our answer to that one. All right, we simplified all of our powers, but we're using the gemdas in this situation too. All right. So first of all, if you have negative exponents, move them to the other part of the fraction and make them positive first. Then you can simplify from there with the numerator, simplify the denominator, and then use the quotient rule from then on. Okay. Now this next one here, we have just a couple left. We have a 0 power. So this, we're using that power rule again, which means we multiply. So this has a power of 1. So we get 2 to the power of 0, x to the power of 0, and 7 times 0 is 0. So these are all just to the power of 0. So when I multiply 1 times 1 times 1, we get 1. So anything raised to the power of 0 is 1. You just have to make sure, all right, about positives and negatives sometimes. All right? Because if we had negative 2 to the power of 0, that is negative 1. But if it was negative 2 to the power of 0, that's positive 1. So just be careful of them to make sure that you are using that correctly. All right, now last one, the bringer of pain. All right, because this is such a complicated one, we need to be careful with it. So we need to use our gemdas correctly in this case. So our exponents first. In the numerator, we have 2 to the 3rd power. X to the 3rd power, y to the 12th, because we have 3 times 1, 3 times 1, and 3 times 4. All right, then we've got 3, x to the negative 3rd, y to the 2nd. In the denominator, 4x to the negative 3rd, and y to the power of 0. All right, now, here's the thing, okay? We have a couple different options of where we go from here. But we're going to simplify the numerator and the denominator first. All right. Work with them as separate pieces. So we have 2 to the 3rd, which is 8. And 8 times 3 is 24. So we're going to do that multiplication first. So we have 24. Now I have x cubed and x to the negative 3rd. So those have the same base. I add those exponents, so we get x to the power of 0, right, which is just the number 1. So you can leave it there or take it out either way. And then we have our y's. Y to the 2nd, y to the 12th. So that gives us y to the 14th. We add them. All right. Go back to our denominator then. So let's use our quotient rule now. All right? We can move the x to the negative 3 in the numerator, and I said to do that, so let's do that anyway. All right, so we still have our 24. X to the 0 is 1. Okay, so 24 times 1 is just 24, so I don't need that. We have y to the 14th. Then this x to the negative 3rd moves to the numerator, becomes x to the positive 3rd. So in the denominator, I have 4. The x to the negative 3rd we move to the numerator to make it positive. Y to the 0 is just 1, so that's just 4 times 1, which is just 4. So we leave it there. Oh, so now to simplify, all I have to do is 24 divided by 4. So this is 6y to the 14th x cubed is the final answer for that problem. But you have to be very careful working through them slowly. Take your time, make sure you're using all the rules correctly. And we have a bonus question. All right, bonus. So if you watch the whole video, then you get a bonus. All right, here's the bonus question. What is negative 53 to the power of 0? And negative 53 to the power of 0 is equal to negative 1, because the 53 is not, the 53 is the only thing that's raised to the 0 power, not the negative. All right? So there's your bonus. If you have that, then you get a bonus point from me today. All right? All right, so that's the end. We're looking at using the power rule or the rules of exponents, negative and 0 in this case.